Everyone, today we have a number theory problem, and the problem is as the following. So we have 49 equals 7 to the power of 2. And the problem says place a 48 between these two digits. So we have 4, 48, 9, and this becomes 67 to the power of 2. In other words, we have a perfect square. And then the problem says if you place another 48, so we have 4, 4, 89 here in between, this becomes again a perfect square, 667 to the power of 2. And if we repeat the same procedure, we always get a perfect square. So the question is, why is it always a perfect square? So we would like to prove that. Let's say n equals to the most general form. So that this will be 4, 4, 4, 8, 8, 8, and 9. And here we have n fours, here we have n minus 1 eighths. Please pay attention that the number of eighths is always 1 less than the number of fours, and then we have 1 9. So the first part can be written, by the first part, I mean this part. This can be written as 4 times 1, 1, 1, n times n 10 to the power of n. So here we have n numbers. So whenever we have a number such as a, b, some z, and then we have here, let's say, some other numbers which have been repeated m times, then we can write this as a, b, z times 10 to the power of m plus whatever number is here. For example, let's call that number n1 plus n1. So this is a very simple result from number theory. And our n capital here will be 4 times 1, 1 times 10 to the power of n. And pay attention that the second part can also be written as 8, 8, 8, n times plus 1. So in other words, I just pulled 1 8 out of the second part, out of 9. And the remainder will be 1. And again, I can do the same thing which I did on the first part. I can write it basically 8 times 1, 1, 1, n times plus 1. So perfect. Now I can factorize the common factor, which is 1, 1, 1, n times. I can write n equals to 1, 1, 1, n times 4 times 10 to the power of n plus 8, and here I have still 1 left. So now we have to expand 1, 1, 1. How can we write that part? So that part can be written as 1, 1, 1 n times can be written as 10 to the power of n minus 1 plus 10 to the power of n minus 2 plus 1. And when this is indeed geometric sum, and whenever we have a geometric sum with, let's say the first element is a, and the factor is q, so we have aq plus aq2 plus some aq to the power of n. So this becomes a times q to the power of n plus 1 minus 1 divided by q minus 1. So here I can write this part as 10 to the power of n minus 1 plus 1, which is basically n minus 1. And pay attention that here a, the first element in this geometric sum, is 1. So that's why here we have 1, and divided by 10 minus 1, which is basically 9. So perfect. So we have that factor simplified. So we can write n equals to 10 to the power of n minus 1 over 9 times this factor here, 4 times to the power of n plus 8, and here we have 1. Let's simplify this further, and then we get 4 over 9 times 10 to the power of 2n, and minus 1 over 9, or 4, basically minus 4 over 9 times 10 to the power of n. And here we get 8 over 9 10 to the power of n minus 8 over 9 plus 1. If we simplify this further, then we get 4 over 9 10 to the power of 2n plus 4 over 9 10 to the power of n plus 1 minus 8 over n over 9 will be 1 over 9. So this is indeed 4 10 to the power of 2n plus 4 10 to the power of n plus 1 over 9. And please pay attention that this is the same as this algebraic identity, a plus b to the power of 2, because now we can write this as 2 times 10 to the power of n plus 1, and we can also put 3 here. This is to the power of 2. So let's take a look at the number in the numerator. And basically the number in the numerator is 2 times 10 to the power of n plus 1. If you pay attention to this number, this is something like 2, 0, 0, n times plus 1. The sum of numbers in this, the sum of digits indeed in this number is always, so the sum of digits is always 3. In other words, this number 2 times 10 to the power of n plus 1 must be always divisible by 3. So this is indeed sum 3 times q, and if we put it inside the parentheses, so we get n equals 3q divided by 3, and by the way, q is a integer number to the power of 2, so in other words, n equals q to the power of 2. So we proved that n is always a perfect square. So if you enjoyed this solution, please like my video and make sure that you subscribe to my channel. I'll be posting more problems.